What if I told you that after the age of 60, your ability to stay strong, energetic, and independent does not just depend on exercise or how much protein you eat, but on how your cells interpret that protein? And what if I also told you that a humble green vegetable might outperform animal protein when it comes to restoring muscle health at the cellular level? Most people over 60 believe that muscle loss, what we call sarcopenia, is just a natural part of aging. But new research tells us that it is not simply a matter of getting older. It is about how our metabolism, mitochondria, and nutrient signaling systems begin to malfunction with time. This breakdown quietly erodes muscle tissue, strength, and mobility long before we feel it. Here is the truth. Starting around our 40s, we lose about 3 to 8% of muscle mass every decade. By our 70s, that rate accelerates dramatically, but it is not irreversible. In fact, emerging data show that certain plant-based compounds can reactivate muscle protein synthesis pathways that typically go dormant with age. Here is what is happening at the cellular level. As we age, our muscle fibers become less responsive to amino acids, especially leucine, one of the key branched-chain amino acids responsible for triggering muscle building through the mTOR pathway. This resistance is called anabolic resistance. It means even if you eat enough protein, your body may not fully use it to repair and build muscle. But here is the fascinating twist. Researchers have discovered that some vegetables, particularly one in the cruciferous family, are packed with compounds that do more than provide protein. They activate signaling pathways that restore mitochondrial efficiency, reduce oxidative stress, and improve nutrient sensing. Essentially, they make your muscles young again, more metabolically intelligent. We are going to unpack all of this today. You will learn which vegetable has been shown to contain more usable protein per calorie than many animal sources, how it enhances cellular repair, and how to integrate it into your diet for maximum impact. We will explore 6 science-backed insights, from amino acid bioavailability to the role of myokines, mitochondrial health, and how micronutrients like sulforaphane can reignite your body's ability to grow and maintain lean muscle even in your 70s. By the end of this episode, you will have a clear, evidence-based blueprint to reverse muscle loss naturally without relying on extreme protein powders or questionable supplements. You will understand what truly drives sarcopenia and how to turn it around using whole foods, movement, and cellular wisdom. So if you are ready to reclaim your strength, sharpen your metabolism, and rebuild your vitality, this might just be the most important conversation you will have about your health this year. If you ask most people why we lose muscle as we age, the answer you will usually hear is simple. We stop exercising, or we do not eat enough protein. Both are true to a degree, but they are only surface-level explanations. The real story runs much deeper, right into your cells, your mitochondria, and the way your body interprets nutritional signals. Here is what is happening at the cellular level. In youth, every time you eat protein, your muscle cells respond with a powerful surge of activity. Amino acids like leucine trigger a molecular switch called the mTOR pathway mechanistic target of rapamycin, which signals your muscle cells to synthesize new proteins. This process is called muscle protein synthesis. It is how your muscles grow stronger after a meal or a workout. But as we age, this response becomes blunted. The same meal that once triggered a strong anabolic signal now produces only a whisper. Scientists call this anabolic resistance. It means your muscle tissue becomes less sensitive to the anabolic effects of amino acids. In practical terms, you might be eating enough protein, but your muscles are not hearing the message. Why does this happen? One major reason is chronic low-grade inflammation, sometimes called inflammaging. Over time, oxidative stress, poor sleep, insulin resistance, and even exposure to environmental toxins drive subtle inflammation throughout the body. These inflammatory signals interfere with mTOR activity and impair the ability of amino acids to enter muscle cells efficiently. Second, there is a mitochondrial connection. Your mitochondria, the powerhouses inside each muscle fiber, begin to falter with age. They generate less ATP, the energy currency your cells use to fuel protein synthesis and repair. When energy production declines, your body prioritizes survival over growth. That means less protein synthesis and slower recovery. Third, hormonal shifts also play a role. Declines in testosterone, estrogen, and growth hormone all reduce the efficiency of muscle protein synthesis. Yet, the most fascinating part of this story is that these declines are not purely inevitable. Many can be slowed or reversed through diet, exercise, and micronutrient support. So, protein alone is not enough. You could eat the highest quality steak or drink protein shakes all day, but if your mitochondria are sluggish and your cells are inflamed, the anabolic signal will never fully reach your muscles. You must restore your cellular sensitivity to protein, and that is where micronutrients, phytonutrients, and lifestyle interventions come in. For example, certain plant compounds like sulforaphane from cruciferous vegetables have been shown to reduce oxidative stress, upregulate detoxification enzymes, and rejuvenate mitochondrial function. This allows your cells to respond more efficiently to amino acids again. Let me break this down with a simple example. Imagine your muscle cell as a house, and amino acids are the bricks you bring to rebuild it. If the workers inside are asleep or the power supply is failing, it does not matter how many bricks you deliver, the house will not be repaired. Restoring mitochondrial energy and reducing inflammation is like waking up those workers and turning the lights back on. If this breakdown is resonating with you so far, go ahead and press the hype button, drop a quick comment, and hit subscribe. It helps more people discover this kind of science-backed health content. In the next section, we will dive into the exciting part, the unexpected vegetable that has been shown to outperform many animal proteins when it comes to stimulating muscle growth and repair. This is where nature truly surprises us. If I told you there is a vegetable that delivers more usable protein per calorie than beef, you might think that sounds impossible. Yet, gram for gram, certain cruciferous vegetables, particularly broccoli, can rival animal sources in their capacity to support muscle health. But the story is not just about protein quantity. It is about protein quality and bioactivity, the way the nutrients communicate with your cells. Broccoli, and its concentrated form, broccoli sprouts, are rich in amino acids, including glutamine, valine, and leucine, all crucial for muscle synthesis. However, what sets broccoli apart is its extraordinary content of sulforaphane, a sulfur-rich compound formed when the plant's enzyme myrosinase reacts with glucoraphanin as you chew or chop it. Here is where it becomes fascinating at the cellular level. Sulforaphane acts as a potent activator of a transcription factor called NRF2, which turns on over 200 genes responsible for antioxidant defense, detoxification, and mitochondrial repair. When NRF2 is activated, it instructs your cells to build more efficient mitochondria, reduce oxidative damage, and enhance energy output, exactly what aging muscle tissue needs to function like it did decades earlier. Now remember that earlier we talked about anabolic resistance when the muscle stops responding effectively to amino acids. Sulforaphane helps reverse that resistance by improving mitochondrial performance and reducing chronic inflammation. That means when you eat protein, whether from eggs, fish, or plants, your body becomes more capable of turning it into new muscle. But broccoli's magic does not end there. It contains indole-3-carbinol, another compound that helps balance estrogen metabolism and supports healthy hormone signaling. This matters because hormones like estrogen and testosterone regulate muscle protein synthesis and recovery. Let me break this down with a simple example. Think of your muscle cell as a factory. Protein provides the raw materials, but sulforaphane acts like the engineer who walks in, upgrades the machinery, and retrains the workers to operate efficiently again. Suddenly, the same amount of raw material produces twice the output. That is how this vegetable amplifies the muscle-building response. Several studies have confirmed these effects. In animal models, sulforaphane supplementation has been shown to enhance mitochondrial biogenesis and protect muscle fibers from atrophy. In human trials, daily consumption of cruciferous vegetables correlates with improved muscle function, lower markers of inflammation, and greater physical performance among older adults. And here is a surprising detail: broccoli's protein is highly digestible and rich in essential amino acids, yet it comes with none of the inflammatory byproducts associated with processed meats. This makes it a clean, efficient, and sustainable source of muscle-building nutrition. Here is why this matters. Building or maintaining muscle after 60 is not just about aesthetics. It is about independence, mobility, and longevity. Every extra pound of lean muscle mass acts as a metabolic shield, lowering the risk of insulin resistance, falls, fractures, and even cognitive decline. So when we talk about broccoli being a muscle-building food, it is not a catchy claim, it is a cellular reality supported by strong mechanistic evidence. By incorporating this vegetable or its sprout form daily, you can enhance nutrient signaling, improve mitochondrial function, and reignite your body's natural capacity for repair. If you are enjoying this breakdown, consider subscribing. I post weekly deep dives into longevity science that decode exactly how nutrition impacts your cellular biology. In our next section, we will explore the powerhouse behind all of this, your mitochondria, and why protecting their function is one of the most powerful anti-aging strategies for your muscles and your entire body. When people think of muscles, they picture strength, tone, or movement. But at the deepest level, muscle health is a story of energy, and that energy is generated inside the mitochondria. These tiny, bean-shaped organelles are the power plants of your cells. They convert nutrients like glucose and fatty acids into adenosine triphosphate, or ATP, the chemical currency your body uses to fuel every contraction, every repair process, and every heartbeat. Here's what is happening at the cellular level. In youth, mitochondria operate like efficient engines producing abundant ATP while keeping oxidative stress in check. But with age, mitochondria accumulate damage in their membranes and DNA. This damage reduces their efficiency, leading to less energy output and more free radical production. The result? Fatigue, slower muscle recovery, and gradual atrophy. Now, here is where the connection to muscle longevity becomes fascinating. Mitochondria do far more than generate energy. They also act as signaling hubs that tell the cell when to repair itself, when to grow, and when to recycle old components through autophagy. When mitochondria are healthy, they send strong grow and repair signals to your muscle tissue. When they are damaged, those signals weaken and muscle breakdown begins to exceed muscle synthesis. This process is accelerated by sedentary behavior, nutrient deficiencies, and chronic inflammation. Yet research has shown something remarkable. Mitochondrial decline is not irreversible. Through certain nutrients and lifestyle interventions, you can trigger mitochondrial biogenesis, which means your body can literally grow new, younger mitochondria inside each cell. One of the strongest triggers of this process is sulforaphane, the compound we discussed in broccoli. By activating the NRF2 pathway, sulforaphane enhances the expression of genes that build and protect mitochondria. But it is not alone in this. Nutrients like coenzyme Q10, alpha-lipoic acid, and carnitine also support mitochondrial efficiency. Let me break this down with a simple analogy. Imagine each muscle cell as a city, and mitochondria as its power grid. When the grid becomes weak and unreliable, the entire city slows down, lights flicker, machines stall, repairs are delayed. Restoring mitochondrial health is like upgrading the entire power system to solar cleaner, stronger, and more sustainable. Suddenly, everything in that city or in your body begins to function at a higher level again. Exercise is one of the most potent mitochondrial stimulators. Resistance training, brisk walking, or even gentle yoga can all increase mitochondrial density. This is because movement sends a hormetic signal, a mild stress that tells your body, adapt, grow stronger, build more mitochondria. That adaptation is at the heart of healthy aging. This is why people who continue strength training and maintain physical activity into their 60s, 70s, and beyond retain significantly more muscle and live longer. Their mitochondria remain active, dynamic, and efficient. So, mitochondria are not just about energy, they are about vitality, resilience, and longevity. And when you nourish them with compounds like sulforaphane, support them through exercise, and protect them with quality sleep, you set the stage for muscle tissue that defies the clock. If you are finding this helpful, tap the hype button and share your thoughts in the comments. And of course, subscribe if you want more deep dives into nutrition and longevity science. In our next section, we will look at the micronutrients that turn on the genes of strength and regeneration, the trace elements and vitamins that literally act as switches for cellular growth and recovery. When most people think about muscle health, they focus on macronutrients, protein, carbohydrates, and fats. But in reality, the most powerful drivers of cellular repair and muscle regeneration often come from the smallest players in your diet. Micronutrients. These are the vitamins, minerals, and phytochemicals that act like microscopic messengers, turning genes on or off, modulating inflammation, and orchestrating how efficiently your cells build and maintain muscle tissue. Here is what is happening at the genetic level. Your DNA contains the blueprint for building muscle proteins, but whether those genes are activated depends on your internal environment, especially on the presence of key micronutrients. Deficiencies in these nutrients can silence growth pathways and amplify inflammation. The good news is that targeted micronutrient intake can do the opposite. It can reactivate dormant repair genes and strengthen your anabolic signaling. Let us begin with vitamin D, one of the most important hormones masquerading as a vitamin. Vitamin D binds to receptors inside muscle cells and promotes protein synthesis. Low vitamin D levels are strongly associated with muscle weakness, poor balance, and a higher risk of falls in older adults. When vitamin D levels are optimized, muscle strength and recovery improve dramatically. Next is magnesium, the quiet conductor of over 300 enzymatic reactions in your body, including those responsible for ATP production and protein formation. Without magnesium, your mitochondria cannot efficiently convert nutrients into energy. It also helps regulate muscle contraction and relaxation, reducing cramps and supporting overall performance. Then there is zinc, which plays a vital role in DNA repair, testosterone production, and immune balance. Zinc deficiency can impair the activity of anabolic hormones and delay muscle recovery after exercise. But perhaps the most fascinating are the phytonutrients, the bioactive plant compounds that influence gene expression through signaling pathways like NRF2 and AMPK. Sulforaphane, found in broccoli, is one of them. Another is quercetin, abundant in onions and apples, which helps increase mitochondrial biogenesis and reduce exercise-induced oxidative stress. Let me break this down with a simple example. Think of your muscle as a high-tech control room filled with switches. Each switch controls a process, one for repair, one for growth, another for inflammation control. Micronutrients are the technicians who know exactly which switches to flip. When they are present, the system runs efficiently. When they are missing, the system goes dark. Here is what research suggests. In older adults, supplementation with vitamin D and magnesium improves muscle function within weeks. Zinc and antioxidant-rich foods reduce inflammatory cytokines that block protein synthesis. And diets rich in cruciferous vegetables upregulate the expression of detoxification and repair genes. This means your genetic destiny is not fixed. You can change how your genes behave by changing what you feed them. That is nutritional epigenetics in action, the science of how diet and lifestyle shape gene activity. This is also why whole foods matter far more than isolated supplements. In nature, nutrients work in synergy. Magnesium supports ATP production, sulforaphane activates NRF2, and vitamin D enhances calcium utilization. Together, they create an internal environment where your cells are not just surviving but thriving. Before we move on, a quick reminder: if you are enjoying this, smash that hype button, like, comment, and subscribe. It really supports the channel and helps spread these tools to more people who want to stay strong and vibrant for life. Up next, we will explore one of the most powerful biological principles in all of longevity science, hormesis, the paradoxical idea that small amounts of stress can actually make your muscles, your mitochondria, and your entire body younger. One of the most surprising discoveries in modern biology is that stress in small, measured doses is not the enemy of longevity. It is the trigger for resilience. This principle is called hormesis, and it describes how your body adapts and grows stronger when exposed to manageable challenges. When you lift weights, fast for short periods, or expose yourself to heat or cold, you are creating a temporary stress that your body perceives as a threat. In response, it activates repair and growth pathways, rebuilding muscle fibers, generating new mitochondria, and improving metabolic efficiency. Without these stressors, those pathways remain dormant. Here is what is happening at the cellular level. During a workout, muscle fibers experience microscopic tears. This damage activates satellite cells, the stem cells of your muscles, which fuse with damaged fibers to create new, stronger ones. The process also triggers mitochondrial biogenesis, the creation of new mitochondria. This is why people who maintain consistent resistance training retain muscle strength and metabolic flexibility deep into old age. But exercise is only one form of hormetic stress. Heat exposure, such as regular sauna use, elevates heat shock protein's specialized molecules that protect your cells from oxidative damage and help refold misfolded proteins. Research from Finland has shown that frequent sauna bathing is linked to lower all-cause mortality and improved cardiovascular function, likely because these heat shock proteins also benefit muscle health and recovery. Cold exposure works on a similar principle. When you expose your body to cold, for example, with a brief cold shower or ice bath, you activate brown adipose tissue and enhance mitochondrial activity. This stimulates metabolic adaptation and strengthens your body's ability to handle future stress. And then there is fasting, perhaps the most ancient hormetic signal. Short-term fasting or time-restricted eating triggers autophagy, the process by which cells clean out damaged components and recycle them into new ones. This process improves mitochondrial function, reduces inflammation, and enhances muscle recovery once nourishment resumes. Let me give you a simple analogy. Imagine your body as a finely tuned orchestra. Hormetic stress is the conductor that keeps every section alert and responsive. Without it, the musicians become complacent, the tempo slows, and the harmony fades. But when the conductor raises the baton through exercise, heat, cold, or fasting, the orchestra comes alive again, precise and powerful. The key is balance. Too much stress and the system breaks. Too little, and it weakens. But the right dose, what scientists call the adaptive zone, leads to enhanced resilience, stronger muscles, and slower cellular aging. This is why the world's longest-lived populations are not those who avoid stress completely, but those who live in environments that naturally challenge them, walking hills daily, experiencing mild hunger, exposure to temperature changes, and living active lives. Their mitochondria stay alert, adaptable, and robust. So, if you are over 60 and want to reverse muscle loss, consider Hormesis your biological training partner. Lift weights, take a brisk walk after meals, spend time in the sauna, or end your shower with 30 seconds of cold water. Each small challenge sends a signal that says, grow, adapt, rebuild. If this science is inspiring you, make sure to hit that hype button and subscribe. Every week, we explore the cutting edge of longevity and cellular health, turning complex research into simple, actionable steps. In our next section, we will tie everything together, a complete, practical longevity protocol that combines food, micronutrients, and hormetic strategies into a powerful daily rhythm for reversing muscle loss after 60. At this point, you understand the science. You know that muscle loss after 60 is not inevitable. It is the result of anabolic resistance, mitochondrial decline, and chronic inflammation, all of which can be reversed when you nourish and challenge your cells intelligently. So now let us turn the science into strategy. What does a daily routine for muscle longevity actually look like? Here is the framework, a simple, sustainable plan grounded in biology, not trends. Number 1, prioritize high-quality protein but pair it with phytonutrients. Aim for at least 1 to 1.2 grams of protein per kilogram of body weight each day, but do not stop there. Combine your protein sources, whether eggs, fish, or lentils, with cruciferous vegetables like broccoli, kale, or Brussels sprouts. The amino acids build muscle, while sulforaphane reactivates your cellular machinery to use that protein efficiently. If you want to maximize results, lightly steam or chop broccoli and let it sit for a few minutes before eating. This allows the enzyme myokines to activate sulforaphane production. You can also add broccoli sprouts, which contain up to 20 times more glucoraphanin in the precursor to sulforaphane than mature broccoli. Number 2, support your mitochondria. Your mitochondria are the engines behind your strength. Support them by including foods rich in coenzyme Q10, like sardines and spinach, magnesium from pumpkin seeds and leafy greens, and polyphenols from berries and green tea. These compounds protect mitochondrial membranes and promote new mitochondrial growth. Regular movement is equally essential. Even short walks after meals or gentle resistance exercises send powerful signals to preserve and grow mitochondria. Remember, inactivity is the fastest way to accelerate decline. Number 3, harness hormetic stress intelligently. Include mild, regular stressors in your week. 2 to 3 strength training sessions. Occasional fasting windows of 12 to 16 hours. A few minutes of heat exposure in a sauna or a short burst of cold exposure. These signals push your biology to adapt, building new mitochondria, improving insulin sensitivity, and enhancing muscle regeneration. Number 4. Micronutrient optimization. Make sure your vitamin D levels are sufficient, ideally in the 40 to 60 nanograms per milliliter range. Ensure you are consuming enough magnesium, zinc, and omega-3 fatty acids daily. If you struggle to get these from food, consider targeted supplementation under medical guidance. Number 5. Protect recovery and sleep. Muscle growth does not happen during training. It happens during rest. Prioritize 7 to 9 hours of quality sleep and aim for consistent circadian rhythms, meaning similar bedtimes and wake times each day. Deep sleep is when growth hormone peaks and tissue repair accelerates. Let me give you a simple analogy. Think of this protocol like tuning a musical instrument. Protein is the string, mitochondria are the vibration, micronutrients are the tension knobs, and sleep is the resonance chamber. When all are in harmony, your body performs with clarity, power, and grace. This is not a quick fix. It is a daily rhythm that reawakens your body's natural intelligence, the built-in ability to adapt, grow, and repair, even well into your 70s or 80s. Before we move into our conclusion, a gentle reminder. If you have been finding this series valuable, press that hype button, leave a comment, and subscribe. Your engagement helps spread this evidence-based health content to others who want to take back control of their aging process. Next, we will close with a concise synthesis, a reflection on everything we have learned, and a clear call to action for anyone ready to start rebuilding strength, energy, and longevity right now. Let us step back for a moment and connect all the threads of what we have explored. We began with a simple but powerful truth that muscle loss after 60 is not inevitable. It is not a sign that your body is breaking down beyond repair. It is a signal that your cells are asking for renewed support, renewed activation, and renewed energy. You now understand that the key to reversing sarcopenia lies not only in eating enough protein, but in restoring your body's ability to use that protein effectively. That means reawakening mitochondrial health, reducing inflammation, and optimizing micronutrient signaling. You discovered that a single vegetable, humble, green, and often overlooked, holds compounds capable of reactivating your muscle-building machinery. Broccoli and its sprouts contain sulforaphane, a molecule that switches on the body's antioxidant defense system, repairs mitochondria, and helps muscles respond again to amino acids. You learned that mitochondria are far more than energy factories. They are command centers of longevity, directing repair and growth throughout your body. When you move your body, expose it to mild stress, and feed it the right nutrients, you literally instruct those mitochondria to multiply, rejuvenate, and power your muscles like they did decades earlier. You also saw how micronutrients, vitamin D, magnesium, zinc, and plant-based phytonutrients can flip genetic switches that strengthen muscle fibers and suppress inflammation. And through the principle of hormesis, you discovered how small, controlled doses of stress resistance training, fasting, sauna, or cold act as biological workouts for your longevity pathways. Now, all of this science leads to one simple truth. Your body is built to adapt. Every muscle cell, every mitochondria, and every gene is waiting for the right signal to repair and grow. You can send that signal every single day through the food you eat, the movement you practice, and the recovery you honor. So here is your challenge. This week, add one of these habits. Maybe it is a handful of broccoli sprouts each day. Maybe it is 2 resistance sessions or a 12-hour overnight fast. Whatever it is, make it consistent. Because consistency, not intensity, is what rewires biology. If this brought you value, like the video, drop a comment sharing what you are adding to your routine, and subscribe to join thousands of others learning how to optimize their health span through evidence-based science. Your body is not aging passively. It is listening to every signal you send. Feed it well, challenge it wisely, and it will reward you with strength, vitality, and resilience at any age.